Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P3, Variant 1, May-June 2021. Let's get started. Strawberries cost $4.20 per kilogram and cream costs $8.56 per liter. Venus buys 1.2 kilograms of strawberries and 125 milliliters of cream. Work out the total cost. The total cost would be equal to the total amount paid for the strawberries, which is $4.20 times 1.2, plus the total amount paid for the cream, which is $8.56 times 125 times 10 raised to the power negative 3. Note that we multiply 125 by 10 raised to the power negative 3 to convert it to liters. When we type this into the calculator, we get $6.11. Ravi has $20. A pineapple costs $1.45. Work out the largest number of pineapples Ravi can buy and the change he receives. To get the number of pineapples Ravi can buy, we divide the amount of money Ravi has, which is $20, by the unit cost of a pineapple, which has been given us $1.45. This gives us 13.79. This simply means Ravi can only buy a maximum of 13 pineapples. Now that we know Ravi can only buy 13 pineapples, we get the change he receives by subtracting the total amount he spends on the pineapples, which is $1.45 times 13 from $20. This gives us $1.15. Abraham has a box of 72 biscuits. He gives 2/9 of the biscuits to his grandmother. He then gives 3/7 of the biscuits that are left to his cousin. Work out how many biscuits Abraham has now. First, let's find the number of biscuits he gives to his grandma. This is 2/9 of 72, which is equal to 16. The remaining biscuits will now be 72 minus 16, and so the number of biscuits he gives to his cousin is 3/7 of 72 minus 16, which is equal to 24. To get the number of biscuits he now has, we subtract the sum of 16 and 24 from 72, which is equal to 32. Flo makes 84 cakes. She sells 35 of these cakes. Calculate the percentage of the cakes that she sells. The percentage of the cake she sells is equal to the total number of cakes she sells, which is 35, divided by the total number of cakes, which is 84, times 100%. This gives us 41.7%, rounded to 3 significant figures. A bag contains 132 sweets. The sweets are shared between Beatrix and Volker in the ratio Beatrix is to Volker equals 5:7. Work out the number of sweets they each receive. The number of sweets Beatrix receives is equal to the ratio share for Beatrix, which is 5, divided by the total ratio of 5 plus 7, which is 12, times 132. This gives us 55. The number of sweets Volker receives is equal to the ratio share for Volker, which is 7, divided by 12, times 132. This gives us 77. Jed sells desserts for $24 each. Each dessert costs $12.80 to make. Work out his percentage profit. His percentage profit is equal to the profit, which is 24 minus $12.80 divided by the cost of making the cake, which is $12.80 times 100%. This gives us 87.5%. The cost to make each dessert increases to $13.60. Jed wants to make the same percentage profit. Work out the new selling price. His initial percentage profit was 87.5%. So if he wants to maintain the same percentage profit, then the new selling price would be $13.60 plus 87.5% of $13.60. This gives us $25.50. Anika asks 15 friends how many marbles they have. The results are shown in the table. Complete the table. To get the sector angle for each row in the table, we divide the frequency for the row by the total frequency, which is 15 times 360 degrees. So for row 1, we have 2 over 15 times 360 degrees, which is equal to 48 degrees. Then we have 8 over 15 times 360 degrees, which is equal to 192 degrees. Then we have 4 over 15 times 360 degrees, which is equal to 96 degrees. And finally, we have 1 over 15 times 360 degrees, which is equal to 24 degrees. Complete the pie charts. Using a protractor, we measure an angle of 48 degrees for the number of people who have 0 marbles. Then we measure an angle of 24 degrees for the number of people who have more than 50 marbles. Then we measure an angle of 96 degrees for the number of people who have 11 to 50 marbles. After this, we are left with 192 degrees, which is for the number of people who have 1 to 10 marbles. Bag A contains 2 black marbles and 3 white marbles. Bag B contains 5 black marbles and 8 white marbles. Write down the probability that a marble picked at random from bag A is black. This probability is equal to the number of black marbles in bag A, which is 2, divided by the total number of marbles, which is 5. Toby says, you are more likely to pick a black marble at random from bag B than from bag A because bag B has more black marbles. Is Toby correct? Give a reason for your answer. The probability of picking a black marble from bag A is 0.4, and the probability of picking a black marble from bag B is 0.385. Based on this, Toby is not correct because the probability for picking a black marble from bag A is higher, which simply means it is more likely to pick a black marble at random from bag A. Toby adds some marbles to bag B. The probability of picking a black marble at random from either bag is now the same. Work out the smallest number of black marbles and white marbles he adds to bag B. We know the probability of picking a black marble from bag B is 5 over 13. And we also know that the probability of picking a black marble from bag A is 2 over 5. To get probabilities equal to 2 over 5, we need to get fractions equivalent to 2 over 5. So when we multiply the numerator and denominator by 2, we get 4 over 10. We can't achieve this with bag B since there are already 5 black marbles in the bag. So now, when we multiply the numerator and denominator by 3, we get 6 over 15. In this case, we need to have 6 black marbles and 15 minus 6, which is 9 white marbles. There are already 5 black marbles and 8 white marbles in bag B. This means Toby needs to add one more black marble and one more white marble to bag B. The scale drawing shows the position of town R on a map. The scale is 1 centimeter represents 5 kilometers. Town M is 36 kilometers from R on a bearing of 163 degrees. Mark the position of M on the map. First, let's set up the scale ratio using the given conversion. When we cross multiply and make x the subject, this is what we have, which is equal to 7.2 centimeters. So on the scale drawing, we first need to measure an angle of 163 degrees from the north of point R. Then we pin the position of point M along this bearing such that M is 7.2 centimeters from R. A railway track 36 kilometers long is to be built in a straight line from R to M. The track costs $1,070 per meter to build. Work out the cost of building the track. First, let's set up the ratio. If building 1 meter of the rail track costs $1,070, then we want to find the cost of building a 36-kilometer railway track. This is what we are calling x. When we cross multiply and make x the subject, this is what we have, which is equal to $38,520,000. 15 people can build 60 meters of track per day. Work out how many days it will take 45 people to build the whole track. If 15 people can build 60 meters of track per day, we want to find the number of meters of track that can be completed in a day with 45 people. This is what we are calling x. When we cross multiply and make x the subject, this is what we have, which is equal to 180 meters of track per day. So now, if we know that 180 meters of track can be built in one day, we want to find the number of days it would take to build 36 kilometers of track. This is what we are calling x. When we cross multiply and make x the subject, this is what we have. Note that we convert 36 kilometers to meters by multiplying 36 by 10 cubed. When we type this into the calculator, we get 20 days. Trains will travel the 36 kilometers at an average speed of 75 kilometers per hour. Work out the journey time. Give your answer in minutes. We know that speed equals distance traveled divided by the time taken to cover the distance. In this case, we want to find t, so we make t the subject. The distance d has been given as 36 kilometers and the speed v has been given as 75 kilometers per hour. When we type this into the calculator, we get 0.48 hours. We need to convert this to minutes. 1 hour is 60 minutes. So to convert 0.48 hours to minutes, we multiply 0.48 by 60. This gives us 28.8 minutes. Town K is on a bearing of 312 degrees from R. Work out the bearing of R from K. In the illustration, we've marked the bearing of K from R. We've also marked the bearing of R from K as alpha. These two are interior angles, which means they add up to 180 degrees. We get this angle by subtracting 312 degrees from 360 degrees, giving us 48 degrees. So we have alpha plus 48 degrees equals 180 degrees. When we subtract 48 from both sides, we get alpha equals 132 degrees. The diagram shows a line L and 2 points A and B on a grid. Write down the coordinates of point A. When we map point A onto the x-axis, we get -2. And when we map it to the y-axis, we get 4. So we have -2, 4. Find the gradient of line L. To get the gradient of line L, we need 2 points on the line. In this case, we are using the coordinates of points A and B on the line. By applying the gradient formula, we have m equals 4 minus 0 divided by -2 minus 6, which is equal to -0.5. Write down the equation of line L in the form y equals mx plus c. All we need to do is find the values of m and c and plug in these values into y equals mx plus c. We've already found the value of m in the previous question to be -0.5. We can easily get the value of c by picking the value on the y-axis through which line L passes. This value is 3. So we have y equals -0.5x plus 3. Draw a line that is perpendicular to line L and passes through the point A. With the help of a protractor or a set square, we measure and mark an angle of 90 degrees. Then we draw a line from the 90-degree mark passing through point A. This line crosses the x-axis at point C. Mark point C on the grid and write down the coordinates of point C. On the grid, we've marked point C, and we see that point C has coordinates -4, 0. Find by measuring the perimeter of triangle ABC. Using a ruler, we measure the sides of triangle ABC. So we have 9 centimeters, 4.5 centimeters, and 10 centimeters. So for the perimeter of triangle ABC, we sum up all the sides. This gives us 23.5 centimeters. The diagram shows the graph of y equals k over x for x is greater than and equal to 1 and less than and equal to 8. Use the graph to find the value of x when y equals 4. On the grid, when we map 4 from the y-axis onto the graph, we get x to be 2. Show that k equals 8. To get the value of k, we can plug in the x and y value we found in part A into y equals k over x. So we have 4 equals k over 2. When we multiply both sides by 2, we have k equals 8. Calculate the value of y when x equals 250. So we have y equals 8 over 250, which is equal to 0.032. Complete this table of values for y equals 8 over x. When we plug in x equals -8 into y equals 8 over x, we get y equals -1. For x equals -4, we have y equals -2. For x equals -2, we have y equals -4. And for x equals -1, we have y equals -8. On the grid, draw the graph of y equals 8 over x for x is greater than and equal to -8 and less than and equal to -1. So on the grid, we plot all the points in the table and connect the points with a smooth line. Write down the equation of each line of symmetry of the graph. The two lines of symmetry of the graph are y equals x and y equals negative x. The diagram shows three triangles A, B, and C on a 1 centimeter square grid. Describe fully the single transformation that maps triangle A onto triangle B. When we look at triangle A and its image, triangle B, we can tell straight away that this is an enlargement by a scale factor of 4. We have a positive scale factor in this case because both triangles have the same orientation. Now we need to find the center of enlargement, which we get by connecting at least two corresponding points on both triangles. When we do this, we get the center of enlargement to be -4, -5. And so the full description here is enlargement by a scale factor of 4 about the center -4, -5. Describe fully the single transformation that maps triangle A onto triangle C. When we look at triangles A and C, we can tell straight away that this is a rotation 90 degrees in the clockwise direction. So now we need to identify the center of rotation. For a 90-degree rotation, the way to determine the center of rotation is this. We draw a line to connect at least two corresponding points on both triangles A and C. Then we need to draw the perpendicular bisectors of these lines. The intersection point of the bisectors is the center of rotation. In this case, the center is the origin. And so the full description for this transformation would be rotation 90 degrees clockwise about the origin. On the grid, draw the image of triangle A after a translation by the vector -5, 4. For this translation, the translation vector dictates that we move each of the vertices of triangle A 5 units to the left and 4 units upwards. On the diagram, the movement for point C has been shown. After repeating the same process for the other points as well, we are able to map out the translated image of triangle A. On the grid, draw the image of triangle A after a reflection in the line x equals -4.5. So first, we draw the line of reflection, which is x equals -4.5. Then from here, we need to reflect the vertices of triangle A in the line x equals -4.5. So for point A on the triangle, since we move 1.5 units to the left to touch the line of reflection, we also need to move 1.5 units to the left from the line of reflection to pin the new position of point A. We need to repeat the same process for points B and C on the triangle as well. When we are done, we are able to map out the reflected image of triangle A. The diagram also shows an angle B in triangle B. Use trigonometry to show that angle B is 63.4 degrees correct to 1 decimal place. To get angle B, we apply SOHCAHTOA. This gives us tan B equals 8 centimeters divided by 4 centimeters. When we make B the subject, we have tan inverse of 8/4. When we type this into the calculator, we get 63.43 degrees, which is approximately 63.4 degrees rounded to 1 decimal place. Two new triangles, D and E, are made from triangle B as shown in the diagram. Are all three triangles similar? Give a reason for your answer. Yes, the three triangles are similar because all the angles in the triangles are equal. Martin, Suki, and Pierre make clocks. Write an expression for the total number of clocks they make in 1 week. Give your expression in its simplest form. Okay, so in 1 week, we are told Martin makes X clocks. Suki makes 3 fewer clocks than Martin. This is what we represented with X minus 3. Pierre makes twice as many clocks as Suki, so we have 2 times X minus 3. And so the total number of clocks made in 1 week is X plus X minus 3 plus 2 times X minus 3. When we expand the brackets, 2 times X is 2X and 2 times negative 3 is negative 6. When we group like terms, X plus 2X is 4X and minus 3 minus 6 is minus 9. So we have 4X minus 9. The total number of clocks they make in 1 week is 35. Work out the value of X. If the total number of clocks they make in 1 week is 35, then we have 4x minus 9 equals 35. When we add 9 to both sides, we have 4x equals 44. And when we divide both sides by 4, we have x equals 11. Work out how many more clocks Pierre makes than Martin. In other words, we are to find the difference between the number of clocks Pierre and Martin make. Martin makes X clocks, which we found to be 11. Pierre makes 2 times X minus 3 clocks, so 2 times 11 minus 3 is 16. So now the difference would be 16 minus 11, which is equal to 5. Complete the clock diagram to show the time 2:30 p.m. The hour hand, which is the short hand of the clock, would be between 2 and 3, and the minute hand, which is the long hand, would be on 6. Calculate the obtuse angle between the hands of the clock at 2:30 p.m. There are 12 equal divisions on the clock. The region between the hands of the clock covers 3.5 of the 12 divisions. So the angle would be 3.5 over 12 times 360 degrees, which is equal to 105 degrees. Work out the number of seconds in 10 days. Give your answer in standard form. First, we need to find the number of seconds in 10 days. So we multiply 10 days by 24 because there are 24 hours in a day. And we multiply this by 3,600 because there are 3,600 seconds in an hour. When we type this into the calculator, we get 864,000 seconds. To get this number in standard form, we move the decimal point from the end of the number to a position after the first non-zero digit. This gives us 8.64. Since we moved the decimal point 5 units to the left, we multiply 8.64 by 10 raised to the power 5. A clock is started at 15 o'clock. The clock is not working correctly and is slow. The clock loses 8 minutes every hour. So after 1 hour, the clock shows 15:52. What time will the clock show 3.5 hours after it started? So if for every 1 hour, 8 minutes is lost, we want to find the number of minutes that will be lost in 3.5 hours. This is what we are calling x. When we cross multiply and make x the subject, this is what we have, which is equal to 28 minutes. To get the actual time, we add 3 hours 30 minutes to 15 o'clock. Under the minute column, 0 plus 30 is 30, and under the hour column, 15 plus 3 is 18. So we have 18:30. To get the actual reading on the faulty clock, we subtract 28 minutes from 18:30. Under the minute column, 30 minus 28 is 2, and under the hour column, 18 minus 0 is 18. So we have 18:02. The times on two clocks are checked regularly. One clock is checked every 6 days. The other clock is checked every 8 days. Both clocks are checked on 1st January 2021. Find the number of days during 2021 when both clocks will be checked on the same day. There are 365 days in 2021. So if clock 1 is checked after every 6 days and clock 2 is checked after every 8 days, we see that the LCM of 6 and 8, which is 24, tells us that the clocks will be checked on the same day after every 24 days. So the number of times the clocks will be checked on the same day would be 365 divided by 24, which gives us 15 days. When we add 15 to the first check at the beginning of the year, we get 16. A, B, and C lie on a circle center O, diameter AC. Complete this statement. Angle ABC is 90 degrees because blank. This is because an angle formed in a semicircle is 90 degrees. Work out the area of triangle ABC. The area of triangle ABC is half of its base, which is 6 centimeters, times its height, which is 10 centimeters. This gives us 30 centimeters squared. Work out AC. We can get AC by applying the Pythagoras theorem to triangle ABC. This gives us AC squared equals AB squared plus BC squared. AB is 6 centimeters and BC is 10 centimeters. When we plug in these values into the equation and make AC the subject, this is what we have, which is equal to 11.7 centimeters rounded to 3 significant figures. Make R the subject of the formula A equals pi r squared. When we divide both sides by pi, this is what we have. To make R the subject, we take square root of both sides. This gives us R equals square root of A over pi. The diagram shows a circle inside the square. The circle touches the 4 sides of the square. The area of the square is 81 centimeters squared. Calculate the shaded area. The shaded area is equal to the area of the square minus the area of the circle. We've already been given the area of the square, so we need to find the area of the circle, which is pi r squared. We've not been given the radius r of the circle, so that's what we are going to find. Here is the formula for the area of a square. The circle fits perfectly into the square, so the side of the square is the same as 2r. And we've been given the area of the square to be 81 centimeters squared. 2r all squared is 4r squared. When we divide both sides by 4, we have r squared equals 20.25. And when we take square root of both sides, we have r equals 4.5. Now that we have the value of r, the shaded area is 81 minus pi times 4.5 squared, which is equal to 17.4 centimeters squared rounded to 3 significant figures. The universal set E contains numbers from 1 to 12. Set E contains even numbers and set M contains multiples of 3. Complete the Venn diagram. The elements in set E are 2, 4, 6, 8, 10, and 12. And the elements in set M are 3, 6, 9, and 12. The elements common to both sets are 6 and 12. The elements in set E that are not in set M are 2, 4, 8, and 10. And the elements in set M that are not in set E are 3 and 9. The remaining elements in the universal set that are neither in sets E or M are 1, 5, 7, and 11. Write down the number of elements in E union M. The number of elements in this region are 8 in total. A number is chosen at random from the universal set E. Write down the probability that the number is in the set E intersection M. This probability is equal to the number of elements in E intersection M, which is 2, divided by the total number of elements, which is 12. 2 goes into 12 one time and goes into 12 6 times. So we have 1 over 6. Meg says that an even number cannot be a prime number. Is she correct? Give a reason for your answer. No, Meg is not correct because 2 is an even and prime number. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.